Hi there. So we are now in South Padre Island, which is pretty much the southernmost tip of Texas. And I'm not sure if I'm going to be able to upload these videos from here. The internet speeds are kind of slow. Um, but as you can see, I'm wearing a t-shirt and shorts, and it's like 10 o'clock at night. And we're in an RV park, so hopefully I'm talking loud enough that you can hear, but other people can't hear. Um, but it's beautiful. We've had beautiful weather. We had 3 days in San Antonio, and just been a great vacation so far. So, but let's jump right into it because limited on time, as you are probably aware. So, lesson 117 is talking about it's showing you symbols to represent um, the different sets of numbers. So we have the natural numbers, the whole numbers, the integers, rational, irrational. Um, so this chapter, this lesson talks about using single letters to represent those sets of numbers, such that you can actually write an equation or a set of equations in a real condensed format for future math courses that you'll take. So let's jump right into it. So the first thing is for the natural numbers. Now they're going to be, I'm going to write them um, you know, basically a little bit different than the book because I can't necessarily write exactly, but so for a natural number they have kind of this double bar n, so it's got a double bar and then, and I'm not sure that lessons or the courses that I've taken before, I don't know that it's critical to have this thicker part of the end here, but I don't even know how you do that. Maybe Microsoft Word has the ability to do that. So this is natural numbers. Um, so natural, and hopefully I'm going to try and stay maybe on a parallel line. I think it's too hard to read up there. And natural numbers are the counting, natural or counting numbers. So we have 1, 2, 3, and so on. And then for whole numbers, they just use a standard capital W. So there's no double thickness of the W. I'm not sure why the difference there. And as you can see, we have bugs all around. You can see those in the video. When we first got here, there was, I think, a black widow in the electric box in the RV park. We turned the lights on. We had cockroaches all over the floor here. And we caught a praying mantis already within like 10 minutes of being here. So it's fun. We're looking forward to trying to find sea turtles. That's the goal of this trip down here. Okay, so whole numbers, of course, are the natural numbers, and also the number 0, and then we also have a z, capital Z, represents integers. So this is minus 1, 0, 1, 2, so on. So basically, whole numbers include 0, natural including 0, and then integers are the whole numbers plus all the negative of the natural numbers. This is all a refresher, but the main thing that's new is the symbol here. A Q, and we have a thickness on the left side of the Q, and these are the rational numbers. And as you recall, rational ratio, meaning that you can write the number as a fraction. And then we also have irrational, which is a capital P. And finally, not finally, two more here. We have a double bar on R here, double thickness. I don't know what you call that. Double bar, I don't know why I keep saying it. This is the set of real numbers. So big R there. And then finally, we have complex. It's a little bit thicker C on the side there. And this is complex. Again, I hope you can hear me in this video session. Okay, so that tells you how you can write these sets. And then let's jump into what we're going to do with that. And I lost my brown pen that worked well, but I found that these blue ones are working. So maybe it's just the purple that doesn't work. And we were kind of rushed last week, and of course a little bit rushed tonight, and it's just trying to keep the video short enough that it has everything you need, but it doesn't take forever to upload. Okay, so So the way you can write, how we'd write an equation that uses this notation, it's on page 477, but basically might have something like A equals, and this curly bracket, or curly brace, x, this sort of like an E curved E, and then maybe something like this, and then a bar, and then x plus 2 greater than 4, and then close the bracket. So what does this mean? Before I even looked at this, it looked familiar to me from my previous lessons, and how I'd read this is A is the set of all values x, such that x is an element of the integer set, and such that x plus 2 is greater than 4. The way they read it, similar, A is the set whose members x are integers, such that x plus 2 is greater than 4. So the bar here is such that this symbol means x is an element of this set, and then these brackets say that A is a set. So A is a set of values x such that x is an element of integers, and also such that x plus 2 is greater than 4. Anyways, but you can probably stick with what the book says on how you read this, but I read a little bit differently, but same thing. So, and in previous lessons we'd write this as x plus 2 greater than 4, and then we'd use this little semicolon, and then we'd say where the domain is a set of integers. So these mean the same thing, but you'll find that when you get to multiple equations, like we have in this example, so let's show another example, you'll find that you actually a little more compact with its new format. So let's do one of those. So once you get past the notation, writing it, doing the problem is the same as what you've done before. So the notation here is pretty strange. So it's saying it wants you to graph the x comma y, and then they have the element of, and then they have this r squared, which I don't remember seeing that before, but that's fine. And then we have y greater than x plus 2, and, sorry I'm running out of room here, and y is less than minus x, and then close brackets. So how you'd read this is the set of the set whose members are an ordered pair x and y, that are each x and y is an element of the real numbers. So this r squared just means that both of these are elements of that set, where x and I'm sorry, such that y is greater than x plus 2 and y is less than minus x. So previously we'd write it something like this. We'd write y greater than x plus 2 and y less than minus x, where the domain is real. Okay, reals. All right, so from there we would simply we have two linear equations here, so we go ahead and graph it. Y is greater than x plus 2, so the slope is 1, mx plus b. Y-intercept is 2, so we're right here, and here, and here, and here. So here is, and actually it's a dotted line. That's one line, and the other line is y is less than minus x, so it's this one here. And less than meaning everything down here, and greater than everything above here, so the intersection of those is all this. Let me show that in the book there. Okay, that's actually all the examples. So again, it's just notation, getting the notation down. That's it, thanks.